Good morning, good afternoon, good evening, whatever time it is. I do hope that you're having a good time. I'm Andrew Komasinski, and this is the last video as part of a class on critical thinking at Hokkaido University of Education. In this video, we are going to summarize some of the things we learned. We're also going to look at inductive arguments that are generalizations. So far, we have looked at general rules for arguments. We have also looked at deductive arguments, and we have looked at arguments by analogy. So let's go ahead and get started. So some of the terms that will matter this time: induction, generalization, context, limitations, probable, overgeneralize, representative, sample size, sample source, and units. So I'll explain all of these terms as we are going along. So in deductive arguments that we looked at before, some of our key terms were the deductive forms, modus ponens. So if it is hot, then Dr. K is sweating. It is hot, therefore Dr. K is sweating. If it is snowing, then Dr. K will not drive. Dr. K will not drive, therefore it is not snowing. Disjunctive syllogism. Either Dr. K will order spaghetti or pizza. Dr. K will not order spaghetti, therefore Dr. K will order pizza. If Dr. K gets a raise, then Dr. K is happy. If Dr. K is happy, then he greets you warmly. If Dr. K gets a raise, then Dr. K greets you warmly. And finally, dilemma. So either it is rainy or it is sunny. If it is rainy, then Dr. K will stay home and watch a movie. If it is sunny, then Dr. K will go outside for a walk. Therefore, Dr. K will either watch a movie or go for a walk. We also looked at four operators. So we looked at and, or, not, and then if then. So we looked at the concept of validity and how to test for validity using both truth tables and the short circuit method. And I believe I mentioned in passing inference rules, but maybe it wasn't an important topic. We also looked at being truth preserving, which means to be a valid deductive argument such that if you have all true premises, then your conclusion must be true. Soundness, which is when you have a valid deductive argument that has true premises. When looking at deductive arguments, a deductive argument itself cannot be true or false. It can be valid or invalid. Each individual statement can be true or false, but statements themselves cannot be valid or invalid. So again, the deductive argument is like the team. The statements are like the players. Each player can be healthy or sick, but a team can't be healthy or sick. A team can play well together or not play well together. So true or false looks at what happens in the world. So it is either true or false that it is -8 right now. So valid or invalid looks at whether or not the rules were followed that will make an argument truth preserving. If it is a carrot, then I don't like it. It is a carrot, therefore I don't like it. So this would be a modus ponens example. So the things that are true or false evaluate what is the case in this world, and things that are valid or invalid evaluate whether it is truth preserving. So sound means you can have true premises and a valid structure, and this will guarantee you a true conclusion. In an inductive argument, we build on experience to reach our conclusion. This can be either direct or indirect. The conclusion we're going to reach for this type of inductive argument is a generalization. So we're going to take a claim about one thing or two things or three things, and we're going to make it a claim about everything or at least about more things. Here's a sample inductive argument. Everyone I met in Sapporo speaks English. Everyone I met in Asahikawa speaks English. Therefore, everyone in Hokkaido speaks English. So the idea here is that I have one person, another person, or many people at these places, and I make a generalization about the whole of Hokkaido. So generalization is an ippanka, something I'm speaking about multiple things at once of. Then the basic concept is that we make a larger claim that's bigger than just the things that were our premises. Let's compare this again with a deductive argument. In a deductive argument, good form means it's valid, or if it has no good form, it's invalid. If it has good form plus true premises, the conclusion must be true. It uses a limited number of operators, and it uses the statements, it never guesses. In Japanese, it is an en-ekiteki ronsho. An inductive argument is going to be strong or weak. Even if it has really good form, even if it's a very strong inductive argument, the conclusion can still be false. It can accept any of a number of styles. It doesn't have to follow quite so tight of rules. It's always a guess of sorts. And this in Japanese is a kinoteki ronsho. In an inductive argument, again, inductive arguments are not true or false. True or false applies to statements. The inductive argument itself is strong or weak. So with the deductive argument, it was valid or invalid. Here it's strong or weak. Statements in inductive arguments can be true or false. Inductive arguments themselves cannot be true or false. So true or false looks at whether or not something is the case in the world. So is it 8 degrees outside right now? If it is, if it's -8, this is true. If it is not, it is false. Strong or weak shows how probable our conclusion is. So the last maybe 50 times I ate cauliflower, I didn't like it, so probably I won't like it the next time, but it's no guarantee. Okay, since being truth-preserving means that we can guarantee a true conclusion, this is very, very handy. Inductive arguments don't have this. They only have being strong or weak, whereas with deductive arguments, they were valid or invalid. So with inductive arguments, we will decide whether they're strong or weak in much the same way as we did last week with the argument by analogy. In deductive arguments, we just look at the short list of rules and we can evaluate that in a very simple fashion to figure out whether or not it will be truth-preserving. So inductive arguments, strong or weak. Strong, likely to convince. This means that the conclusion can be false even when all of the premises are true. A weak argument does not mean the conclusion is false. This is actually a very strange thing about inductive arguments. It just means the argument does not support that conclusion. Conversely, a strong argument does not mean the conclusion is true. It just means that that argument leads us to believe the conclusion is probably true. So let's compare. With arguments by analogy, we could say that it was strong based on the number of similarities, variety of similarities, relevance of similarities, lack of dissimilarity. Generalization is basically the same concept, number of examples, variety of examples, contrast with its background, and lack of counterexamples. So these are the 4 principles that we're going to look at to evaluate inductive arguments. So here's an example. The first time I came to Asahikawa, it snowed. The second time it snowed. The third time it snowed. Therefore, it snows a lot in Asahikawa. So if it snowed 3 times, I could draw this conclusion. If I did that, I would have 3 relevant examples. They would all be ones that kind of fit the pattern. We would need to know a few more details to know whether this is going to be strong enough. We can make it weaker. So we can instantly make it weaker. The first time I came to Asahikawa, it snowed. It snows a lot in Asahikawa. This is weaker because now we have only 1 example. We can make it stronger. The first time I came to Asahikawa, it snowed. The second time I came to Asahikawa, it snowed. The third time I came to Asahikawa, it snowed. The 4th time I came to Asahikawa, it snowed. On and on and on. The 100th time I came to Asahikawa, it snowed. Therefore, it snows a lot in Asahikawa. This is much stronger because we have much more data. So if we looked at it this way, we would have this giant chart of everything just going straight across. So this is one of our rules. The more examples make a stronger inductive argument. Second rule, use representative samples. So representative means typical of a class, group, or body of opinion. Representative is an example of a group or a class that's a daihyo, or to say that they're reigai de wa nai. To say that it's very normal for the sort of thing we are looking at. So this is a little bit different than like a deity or things like that. And this is not someone that works in the Diet or in Congress, but this is the idea that they match what we're trying to describe. So we're looking for things that are typical. So someone of normal height, if we want to talk about height, someone with a standard education for many types of questions, someone with a typical life story, if we want to generalize about people. So let's just look at the opposite, and maybe this will help us. So if our sample goal is height, someone who's exceptional that we don't want to look at is a tall basketball player. Representative maybe for us, a random American adult. Exceptional in the other direction, the president of the little people of America. So this is a group for people who are on the smaller side. Intelligence. So if we look at Mensa members, this is probably a bad group to be looking at to decide who is intelligent in the normal sense, or evaluating people who are normal in intelligence. And possibly a special education class is the opposite side. So a random high school is a much better place to go. Eye color. So blue eye color is something that is specific to Northern Europe. So if we go to Northern Europe, we're going to get something that's exceptional. If we go somewhere random on the planet, we should get something average. If we go to East Asia, almost everyone has brown eyes, so this is also a bad location choice. Knowledge of Japanese. If we go to Japan, we'll find an exceptional number of people who can speak Japanese. If we went somewhere random on the planet, maybe this is better for knowing how much people know about Japanese in the world. If we went to the Amazon River Basin and visited some tribes that don't encounter the world, that'd be a bad sample for the opposite reason. They don't have the normal experience. So we're looking for things that are very normal, because we're trying to make educated guesses. So here's the idea of what non-representative means. So if we have one red dot, we have one red dot over here, this red dot is different than all of the blue dots. It's separated by location, it's also separated by colors, so it makes no sense to use this to talk about the whole or to talk about blue in general. So, on the other hand, if they're all scattered together, if red and blue are basically distributed in the same way, so in the same ranges, same values, it seems we could use just the red ones to talk about the whole. This seems like it would not be a large problem for what we want to do. So let's look at some further examples. So I've highlighted why I think these may not be great, but we'll find out. Everyone in my house can speak English, therefore everyone in Japan can speak English. The immediate question is, does my house match a standard Japanese household? Is it sufficiently similar for this to be a good idea? Next one, most people in Hokkaido are Japanese by nationality. Most Japanese by nationality speak Japanese, therefore most people in Hokkaido speak Japanese. So here we are combining two most claims. This one seems a little bit better. Most people I know in Asahikawa go to HE Asahikawa, therefore most people in Asahikawa go to HE Asahikawa. This seems weak to me because I work at HE Asahikawa, which means that my encounters are more with students and people who work there than the average person in the city. So, the basic idea is we want to ask, does this make sense to speak in general about other things? The other thing is we have to consider context, so this is a very related idea. So numbers only have meaning when they have units and context. The temperature is 80, so it is hot outside. So it matters a lot. When I say 80, do I mean 80 centigrade, which would be very hot? Do I mean 80 Kelvin, which would be extremely cold? Humans can't live. And do I mean 80 Fahrenheit, which would mean a summer day? I did well because I got a 10 on the test. So well, immediate question, is the test out of 100? Is the test out of 10? This changes things a lot, is we need this sort of background to know what any numbers mean. You have 24 left, so you should be fine. So 24 hours, 24 seconds, 24 minutes, 24%. If I don't give people units, these things don't mean anything. So again, it is so hard because last year 10 people passed. So we have to ask, how many people took the test? How many people normally take the test over the last 5 years? Were the people who took the test in those years special? Second one, Dr. K speaks English, so white people speak English, but is Dr. K a good representative of all white people? So for instance, I am an American, I'm highly educated, I live in Japan. This all separates me from most Americans and from most white people in general. Many white people are not from the United States, and they're from parts of Europe where maybe they don't speak English this well. So finally, 3 people at the table were speaking in French, so everyone speaks French. So 3 people at that table, but how many people were at the table? And when we say everyone, do we mean everyone at that table? So we need to be more careful. We want to make our generalizations in a more careful way. This is one of the key things we are trying to do. And part of that is we want to read generalizations carefully. So we want to think about numbers and other things, and we want to consider what we're doing. Most people like many kinds of fruit. So this actually has multiple possible meanings. It could mean most people like apples, most people like oranges, most people like apples and oranges. It actually has not specified between these possibilities. Mostly the work is being done through the words most and many. So through most and many and only, we are getting a variety of things. So we can say most people like only apples, someone likes only strawberries, someone likes all fruit. So from this general statement, most people like many kinds of fruit, could we draw these sorts of claims? Let's consider another one. Most people in Asahikawa can speak Japanese. So could we make it stronger? Could we say everyone in Asahikawa speaks Japanese? Most people at HE Asahikawa speak Japanese. So could we narrow the context? Some people at HE Asahikawa speak Japanese, or someone, so at least one person speaks Japanese. Or even more kind of looser in terms of how strong of a thing we're saying, someone at HE Asahikawa probably speaks Japanese. Let's consider whether we could say any of the following. Most people in Asahikawa can speak Japanese. Could we say everyone in America speaks Japanese? So now we'd be changing the location and drawing a very big generalization. So obviously we can't say that. No one at HE Asahikawa speaks English. So this is a weird claim because our first claim said most people can speak Japanese. It didn't say whether anyone can speak English or not. It seems like we could easily show this is false because I'm speaking to you in English now. Someone at HE Asahikawa probably speaks Japanese. If we know that most people in Asahikawa do, then probably someone at the university can as well. So this would be a very easy generalization to make from the data we have. So one way to avoid overgeneralizing, which is when we make a generalization that's too big, is to look and make sure that we're not using the words all, none, no, every, or must, or cannot. So if we make our conclusion something that is universal, it's going to be much harder to defend than if we make our conclusion smaller. So we can make it weaker by switching to words like many, most, some, probably, and might. Another thing we can do is we can take the area and we can make it smaller. So we can change from all of Asahikawa to just this university, or we can change from this university to just the English major, or to just the Kokugo major, or something like that. So this also can be dangerous. If we started with the English major, we can't immediately jump to the Kokugo major unless the two groups are similar. So we need to keep that in mind when we are making generalizations. Finally, we need to also think about counterexamples. So when we make generalizations, one of the things that can happen is that with a generalization, it is strong or it is weak. And they can always be wrong because they draw a conclusion based on data in this world. So the bigger the claim is, the easier it is for it to be wrong. No American can speak Japanese. This is extremely unlikely to be true. It's very easy to find counterexamples. No Japanese student is taller than Dr. K. This is something where there have been several counterexamples. I've met many students. I've met one in the English major, one in the elementary education major, one or two in the social sciences major, where students are slightly taller than me. Another one, all white people speak English. So we could find white people who cannot speak English. So I know some here in Japan who can speak French or other languages. All Chinese people prefer rice over bread. Again, this all word is creating a problem for us. If we shrink this down, we could have an argument that is more robust, is more strong. As it is, it's quite weak because it's easy to find counterexamples that break it. A counterexample is something that will show the generalization is false. So one of the most famous examples of this is that for a long time, Westerners believed that swans were all white. They hadn't yet learned that there were black swans living in Australia. Another example, I don't accept absence slips. So when you have a sports event or something, I don't care. Handing it to me has no meaning. But if you are missing things due to a Kyoku Field Kenkyu, which is a type of student teaching or any other school-sponsored event, I will accept it. So this is a counterexample to my rule that I accept no absence slips. Another one, so if I said it always snows in Asahikawa, so we have all this snow. If there's a single time that it doesn't snow, then this claim is broken. So if we can find a single day, then this claim would be wrong. So if I had a chart, if I said every point is blue, if a single point is red, that's going to break it. So if I changed it, I can say that most points are blue. So when looking at arguments, think if there is an exception. Think if there's something that breaks that, and be careful to use words like all, none, no, most, every, or few more carefully. So let's summarize what we've learned about inductive arguments, both for arguments by analogy and for generalizations. Both arguments by analogy and generalizations are types of inductive arguments. This means that they are not valid or invalid. They cannot be truth-preserving. Instead, they are strong or weak. A strong argument makes its conclusion likely. A weak argument is one where the conclusion might be true, but even if it is true, that is not based on the argument that we make. So looking at generalizations, a generalization is stronger the more examples it uses as premises, both in number and in kind. A generalization is stronger the more representative its premises are. So looking at how we pick them, did we pick something that is exceptional or something that is representative? Also, to know if a generalization is actually saying anything, we need to contrast it. So we need to know whether the numbers it has mean anything, how it differs from anything else. And finally, we need to check to see, are there counterexamples that are going to make our conclusion false? So comparing the two, both an argument by analogy and a generalization can have all true premises and a false conclusion. In an argument by analogy, we mostly are working from pictures. In an argument that's a generalization, we are working from numbers. In both, number and variety matter. In argument by analogy, the relevance of the similarities also matters directly. In argument by analogy, dissimilarities will break the argument. In generalization, counterexamples or a lack of contrast between what we're generalizing and other things will break the argument and make it very weak. So I want to summarize just one last time all of the things that we have covered this semester. So we've looked at making and evaluating arguments in general. We've looked at the concept of a statement, including premises and conclusions. A statement is something that is true or false. A conclusion is the statement we are trying to convince our reader or listener is true. And the premises are the things that we say to support that conclusion. We looked at avoiding emotional language, we looked at having a good argument order, and we looked at being concise, concrete, and consistent. So being concise is to include only the information that you need for your argument. Being concrete is to, as much as possible, make it clear what it is that we want to say by using the actual things rather than speaking in abstractions or indirectly. And being consistent means use the same term for the same meaning throughout your arguments. With deductive arguments, we looked at the 3 laws of logic. We looked at 5 forms of argument, 4 operators, truth tables, validity, the concept of being truth-preserving, and then finally soundness. So we looked at the law of identity. The thing has the same meaning throughout the argument. We looked at the law of the excluded middle. For any claim, we have to decide, is it true or false? This is also called bivalence. And we looked at the law of non-contradiction. In our system, we cannot allow contradictions. It cannot be the case that A and not A are both true at the same time when A has the same meaning. So we say not, left parentheses A, and not A, right parentheses. We looked at 4 operators, and, which is true when both claims are true, and in all other cases false, or, which is true when either claim is true, and is only false when none of the claims are true, not, which is the opposite of whatever the value was, so if it's true it's false, if it's false it's true, and the conditional, which is true in every case except when the left-hand part is true and the right-hand part is false. In all other cases, it's true. 5 standard forms: modus ponens, modus tollens, disjunctive syllogism, hypothetical syllogism, and dilemma. So we also looked at truth tables, so we went in detail on how to make those and how to check for validity. We also looked at arguments by analogy. In arguments by analogy, we looked at fit, which we understood to be the number of similarities, the diversity of these similarities, the relevance of these similarities, and the lack of countervailing dissimilarities. In generalizations, we looked at the number of examples, the diversity of examples, the background, i.e. the contrast, and the problem of overgeneralization. So I do hope that you gained something from this class. Please remember to ask me questions about anything that I didn't explain well, or anything that you didn't understand. I look forward to seeing you in class or asking your questions online.